on 2.3b, we're going to need to add these to your note card. Hopefully we already did. Please keep them in order of how they are. All right. Does anybody notice anything from writing on your note card? The derivative of tangent is secant squared. The derivative of secant is secant x tan x. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is actually negative cosecant cotangent. Does anybody notice any patterns?
Sin and cos.
The derivative of co. What's the derivative of all the cos? The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. Does anybody see anything? They're all negative. The derivative of every co is negative. Now, am I asking you to memorize that now? No. I just need you to know how to use it. However, before the AP exam, those things will be in your noggin. All right, 2.3b. We're going to prove the derivative of tangent. And you can prove other ones, but this one we're going to derive. Literally derive. Both versions of the word. What is tangent? Sine over cosine. So what I'm going to do is I'm going to derive sine over cosine. And we just learned this rule yesterday. We have a fraction thing going on. So what rule are we going to use? Quotient. We're going to use the quotient rule. So I take the derivative of the top. What's the derivative of the top? What's the derivative of the top? Just cosine. And then times the bottom of cosine. And then minus the derivative of the bottom. What's the derivative of the bottom? Negative sine. And then times the top of sine. All over cosine squared. All right, let's keep going. So what's cosine times cosine? Cosine squared. What's a negative sine times sine? It's going to be plus sine squared. Now you should recognize something. Cosine squared plus sine squared is equal to 1. So this is the same thing as saying 1 over cosine squared. And I can keep going. What's 1 over cosine? Secant. So if I have 1 over cosine squared, that should be what? Secant squared. So we just proved the derivative of tangent is what? Secant squared. All right. Pretty cool?
Yeah.
All right. You could do the same thing with cotangent real quick. Secant and cosecant are a little bit different. All right. Let's put it into use. So I have y is equal to x minus tangent x. And I want to take a derivative. How could I notate taking a derivative of this one? dy dx. Good. So what is the derivative of x? Just 1. Minus, what's the derivative of tangent? Secant squared. So now I'm done. All right, there's no more to go there. All right, let's look at number 2. So now I have y is equal to x secant x. Well, what's going on this one?
They're multiplying.
It's a multiplying thing. So what rule do we use? The product. So the derivative of y is dy dx. And now I need to use the product rule. So what's the derivative of my first? 1 times secant x. And then plus the derivative of my second. So the derivative of secant x is what? Secant x tan x. And then times the first of x. Now, on this one, we could factor out a secant, so I'm actually going to do it. So we're going to factor out a secant x. So what are we left with? 1 plus x tan x. Good. And then we are finished. All right? Really, we're kind of finishing the red, but I just went a little bit further for the blue. Okay? Pretty good? All right. All right, so on this one, I want to show you that we can differentiate two different things to look like two different answers, even though they're the same. They're equivalent. So what I want to prove by this one is if I have to differentiate 1 minus cosine over sine, well, how would we differentiate this? What rule would we have to use? The quotient rule, all right? And let's say your friend is like, I don't want to use the quotient rule, so I'm going to distribute dividing by sine. Well, 1 over sine is what? Cosecant. Cosine over sine is cotangent. And we're going to differentiate that way. Are you allowed to do either one?
Yes.
Yes, and I want to show you that they are equivalent on this. All right. So if one of your friends is working on it this way and the other friend's working on it this way, does that mean, and they look different, does that mean they're wrong? No, they both could be right. That's what I want to prove here. Okay? All right, so on this first one, on the left side, we're going to use the quotient rule. So what's the derivative of the top? What's the derivative of 1 minus cosine x? Sine x, okay, because it's really like a negative, so we have a sine x. Times the bottom of sine x. Minus the derivative of the bottom, which is cosine x. Times the top of 1 minus cosine x. All over sine squared x. Or sine of x squared, sure. All right, so let's simplify it now. So sine x times sine x is sine squared x. Now we're going to distribute this negative cosine. So now I have minus cosine x and then plus cosine squared. All over sine squared. Now, do you notice anything? The what? Sine squared plus cosine squared is equal to 1. So now I have my derivative, dy dx, is equal to 1 minus cosine x all over sine squared x. And I can't really go any further than that. We're done. All right? All right, let's look at the right side now. So now I have cosecant minus cotangent. If I just distributed dividing by sine, that's what it would look like. So now, let's take a derivative. So what is the derivative of cosecant? Negative cosecant cotangent. And then, what's the derivative of cotangent? Negative cosecant squared. So this is going to be a plus cosecant squared x. Right? You guys are just using your note card. Right? Just use your note card. That's fine for now. Now, in most cases, I'd be done taking a derivative right there. True? All right, I could be done right there. We can't really go much further. However, do you guys think in terms of cosecant and cotangent in your head? Not really. All right, what do you convert them all to? Sine and cosine. So that's what I want to do here. That's what I want to prove. So this cosecant is really negative 1 over sine. Cotangent's really what? Cosine over sine. Plus, what is cosecant squared? 1 over sine squared. Now, do you see anything beautiful that happened? They had common denominators, and the common denominator is what? Sine squared. And then I have negative 1 times cosine, which is negative cosine, and then I still have plus 1. Do you see that they're equivalent? All right. Even though normally I would actually probably stop right there in the black right here. All right. However, if you put them all in sines and cosines, they're the same. All right. Pretty cool? All right. On this page, I want to talk about what's the hard part about the product and the quotient rule. Is it the actual calculus that's the hard part of the product and the quotient rule? Is the calculus the hard part? No. What's the hard part? The algebra, the simplifications of it. That's the hard part, and that's what I want to show you from here. So the hard part is actually like distributing or foiling or combining like terms and stuff like that. All right, or just doing it in general. All right, right, TJ?
Yep.
All right, and so that's the hard part, is the simplification process. Is it's not really the calculus. Okay, so keep on going with the algebra. All right, let's talk about derivatives. So if you have a position function, that's s of t. If I talk about instantaneous velocity, what do? I take a what? A derivative. So the derivative of position is velocity.
Yes.
So we can notate that by s prime of t or v of t. It means the same thing. And then if I take a derivative of velocity, that's actually what? Acceleration. And what kind of acceleration is it? If I'm taking derivative, it's what? Instantaneous acceleration. All right? So if I go from position and I need to get to acceleration, how many times am I taking a derivative? Twice. All right? I'm taking it twice. So most of the time we're kind of good with acceleration. We take two derivatives and we're done. However, every now and then we need to get to a third derivative. And that third derivative still has a special name. It's actually called a jerk. All right? The third derivative is a jerk. I'll tell you a quick story. When I was in college, I had this guy that parked next to me really close, and I still had one of those window markers. You know, the window markers that you can like write on cars and stuff. All right. So I had a window marker in my car, but this guy like parked really, really close to me. So I was like, actually, I don't know if it was a guy or a girl, but I wrote this on their window. I sure did.
Oh, I get it. I get the.
I told them.
Yep.
All right.
I'm sure they got that one.
Finally.
I don't know if they really got it or not. However,
Finally,
I totally called them a jerk.
Finally, I
All
understand.
right. So if anybody parks really close to you, call them a third derivative and call it a day. All right. They probably won't have any idea what they're talking about. All right. Pretty good. All right.
I understand the thing.
All right. Here we go. There we go. Jacob's gonna read for us. Jacob's gonna read.
Automobile's velocity starting from rest is v of t equals 100t over 2t plus 15, where v is measured in feet per second. Find the acceleration at a 5 seconds.
All right, 5 seconds. That's what we're gonna do. So I'm given a what function? A velocity function. What's being asked? Acceleration. So what do we need to do? Take a derivative. And so I need to get to v prime, which I can notate by a of t. All right? I can call it v prime or I can call it a of t. They mean the same thing. All right? And AP readers will understand which one. Okay? It doesn't matter. So what rule do we have to use here? The quotient rule. So let's take the derivative of the top, which is 100 times 2t plus 15. And then what? Minus. Hey, we're getting good. Times? Or then what? What's the derivative of the bottom? 2 times 100t. All over 2t plus 15 squared. Now we got to do the simplifications of it. So let's distribute the 100 so we end up with plus minus all over 2t plus 15 quantity squared. Does anything happen? 200t's cancel. Don't you love it when things cancel? You guys starting to enjoy it when things cancel? Good. All right. So a of t is equal to what? 1500 over the quantity of. Good. So there's my derivative. Now what? I substitute in 5. So now I just substitute in 5. I find a of 5, so I get 1500 over 2 times 5 is 10. 10 plus 15 is 25 squared is 625. And I'm just going to leave it like that because I don't care. What are my units?
Meters per second squared.
Feet per second squared. Now, I want to talk about this a little bit. If I have position, it's just feet. If I take a derivative of position, a first derivative of position is velocity, right?
Yeah.
So it's feet per second to the first power because it's the first derivative. If I take to acceleration, now I'm feet per second squared. Because acceleration is the what? The second derivative. That's why it has a squared. Because it's the what? The jerk would be seconds cubed. All right?
Yeah.
All right, pretty good? Awesome.
Does
Awesome.
the jerk matter?
So we're doing this again. We're doing this again. It's gonna click. It's gonna click here. All right. So here's F, and I want to write F prime and F double prime. But you're gonna get it this time. I know you will. All right. So what kind of function might F be?
Quadratic.
What kind of quadratic? A negative quadratic, right? So negative x squared. What would be the derivative of a negative quadratic? A negative 2x, a negative linear. So the derivative of that would be like this. That would be f prime. Now, we could do it old school. We could say, what's the slope? 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 We could do it that way. We could do it that way because this is super positive, less positive, 0, negative, more negative, more negative. There it is. All right. Now, what's the derivative of this negative linear? A what? A what kind? A negative
Quadratic.
constant. Because this f prime would be kind of like a negative 2x, right? And so f double prime would be like a negative 2. It's a negative constant. Right? Now, I want to get to the jerk because I can. What would be the third derivative? 0. So f triple prime would look like that. All right, let's do it again. So 114. What kind of function might that be? A positive what? Cube. A positive cube. And so what would the derivative of a positive cube be? A positive what? Positive quadratic. So that's what f prime might be. And then what might be the derivative of that?
Linear.
A linear. A what kind of linear? A positive linear. So that could be f double prime. Then I want to keep going because I'm crazy. So what's f triple prime? A positive horizontal. So f triple prime would be a positive horizontal. And I want to keep going. I want to get the fourth derivative. What's the fourth derivative? 0. And so that would be on the x-axis. So that would be the fourth derivative. And yes, that is a Roman numeral. All right. Pretty good? All righty then. All right. There you go.